So my next guest today is Joe Hertline from Indium Corporation. Welcome, Joe. Nice to see you.
Yeah, thank you, Trevor. Great to be here.
Yeah. So the big thing for Indium Corporation this week is to talk about how you're dealing with some of these packaged materials that are starting to run really hot. Obviously, we're talking about things like data centers and that, where some of these chips or parts of the chip get really high thermal excursions. How is Indium approaching that problem, and what sort of changes are you making?
Yeah, thanks, Trevor. It's really an application that we're really focused on because of the power consumption that's really being looked at, and this is primarily driven by AI applications.
Right.
At the data center level, obviously we're looking at thermal challenges, but if we take that all the way down through the rack servers, all the way to the chip level, that's where we're focused. And with the increasing power consumptions, we're talking about kilowatt level, thermal demands at the chip level.
Right.
And that's really incredible. Supporting these applications. And so for us, it's what is the right thermal interface that can enable those applications to be successful.
Right.
The current or the traditional thermal interface materials just lack the bulk properties for obviously thermal conductivity and also sustaining over time. So at Indium, we're experts in metal thermal interface materials, and that's where we're really focused on leveraging the advanced properties of indium as an element, but also different thermal interface materials that we can offer to take to the next level.
So just to get that right, Joe, I want to be sure that the thermal conductivity of the indium as an alloy is 86 watts per meter Kelvin.
That's correct, Trevor, and that's one of the key advantages over conventional thermal interface materials that have about 10 times lower bulk conductivity.
That's going to help with the transfer of power for sure. They're also using liquid cooling on top of these data centers as well, which also helps to reduce the heat as well. But in the long term, there's still a reliability problem because a lot of these things are only lasting 2 to 5 years. So I think there's still a lot of work still to be done.
Yes, for sure. And I would say one of the key considerations, there's many different packaging strategies on how to transfer the heat from the chip into the system. Obviously, you mentioned immersion cooling. That's definitely a growing need just because of the system demands or the demands on the system. One of the advantages, again, with a metal-based thermal interface material, you obviously get that immediate performance, the thermal performance, but the longevity is also far superior. So you don't have degradation over time for things like pump out or bake out, dry out that could occur with other conventional thermal interface materials.
Yes.
You're going to get that longevity.
Yeah, you're not straining them as much as you would be using other materials.
That's right.
No, it's an interesting area. I mean, and as I said earlier, they're moving now towards photonics as well to try and use it as a system for reducing the heat in these data servers.
Yes.
But it's an interesting area. So what else is new out there for Indium? What other things are you working on?
Yeah. So we're looking at obviously the complete ecosystem, I would say, around supporting AI applications. So we talked a lot about our thermal interface materials, how we can get the heat out, quite literally in those systems, but it's also around enabling the broader aspects of the assembly. So even in the advanced packaging side, innovating on some of our semiconductor solder pastes that are intended to really extend reliability performance at that level.
Right.
And also even in the traditional PCB sense, having materials that are lower temperature, but also advancing some of the reliability needs. So one of the products that we continue to focus on is our DuraFuse technology in the PCB side of things, and that's really again an advantage on the low temperature side, but high ductility. Also helps with reliability in certain applications.
On these advanced semiconductor alloys that you're using, I mean, they're using sort of type 6, type 7 pastes and that sort of thing. Does that bring in a whole range of different properties?
Yes, that's right. And really that's around coupling together some of the alloy technologies, and then of course the type 6 or type 7 rheologies on how to apply and how to dispense and how to make it effective for the different applications, whether it be the BGA or flip chip applications and things like that. So.
Yeah, great, excellent. Okay, well, plenty to keep you busy, that's for sure.
Yeah,
Joe, so I want you to thank you for coming in and talking to us about it today.
Yeah, Trevor, thanks a lot. It was great speaking with you.
Thank you.